So 7 years ago, Eric and I reached out to LASA, the Los Angeles Homeless Services Authority, to see if through our research we could help make a dent on one of the biggest crises affecting Los Angeles. The problems they shared with us are exactly the kind that motivate me the most in my work. Problems that are affected by uncertainty and ambiguity, and where data will be biased. My biggest realization was that AI research would actually be needed to effectively address these problems. You see, while AI has had tremendous positive impact and tremendous benefits for our society, the most vulnerable have been left behind. This is due to the inaccessibility of AI in terms of both skills and costs, but also due to potential risks of applying existing AI in this new context, due to lack of transparency, for example. So what if we design AI explicitly to support the most vulnerable, marginalized, and underserved communities? So here's what we're addressing in our work. In LA, we have a massive homelessness crisis. The local housing authority has 28,600 housing resources available to have. These take the form of short or medium-term rental assistance or of long-term housing support service. Most of these resources are already in use. Meanwhile, every night, we have 75,518 people sleeping on the streets or in shelters. And the situation keeps getting worse. The number of people experiencing homelessness keeps growing, and resources can simply not keep up. At the same time, we have severe disparities in homelessness. In LA, while 9% of people are Black, 40% of people experiencing homelessness are Black. In LA, people experiencing homelessness are prioritized for housing due to a vulnerability to it. This is a better paper survey that asks clients about any adverse experiences they have had. The more adverse their experiences, the more likely they are to be prioritized for housing once it becomes available. Our vision with LASA was to use this data, and more generally data from the Homeless Management Information System, to design a system for matching people experiencing homelessness to housing resources that is less unidimensional, that is more outcome-driven, more scientific. We arrived at 3 characteristics that such a system should have. It should be efficient to maximize the number of people who exit homelessness. It should be fair in a way that is sensitive to pre-existing inequalities. And it should be transparent, such that we can justify why someone got a resource over someone else. To design such a system, we first have to define what is fair. It's actually really ambiguous what fairness means in this context. Shall we prioritize those who have been waiting the longest? Or perhaps those who are most likely to be taken advantage of with land and the skills? Or perhaps older people, because they're less likely to find the income needed to get housing. Based on our discussion with stakeholders, the conversation around fairness in homelessness typically revolves around protected characteristics. So things like gender, age, race, and so on. The first thing stakeholders look at is who gets housing, what we call statistical parity in allocation. This requires that all protected groups should get housing at equal rates, so that, for example, the proportion of white people who get housing equals the proportion of Black people who get housing. The second thing stakeholders look at is who exits homelessness, what we call statistical parity in outcomes. This requires that all protected groups should exit homelessness at equal rates, so that, for example, the proportion of white people who exit equals the proportion of Black people who exit. Ideally, we would like to pick a policy in the intersection of these two lists, as such that it satisfies both notions of fairness at the same time. In our research, we show that unfortunately, these two notions are typically incompatible with one another, so there is no clear rule. This raises a number of moral dilemmas. The first one is whether we actually want to depart from parity in allocation, which is perhaps a more traditional notion of fairness, to get to outcome parity. And if we do, we quickly arrive at the second moral dilemma, which asks how far we actually want to go. For example, if we prioritize people based on how likely they are to have resolve, meaning to exit homelessness without support, then we can get closer to outcome parity without deviating too much from allocation parity. If we want to get even closer, we need to use more information. Things like the housing intervention effectiveness, meaning how much each type of housing resource helps different individuals exit homelessness. And when this, so far we haven't done anything controversial, right? We're basically prioritizing people based on their needs. But if we want to get even closer, we need to use more information. Things like unprotected characteristics, for example, information on recent hospital stays, or information on where people sleep at night, and so on. And while this may seem not controversial, what we find in our work is that actually these only help you get closer to outcome parity to the extent that they are predictive of the protected characteristics. And in fact, to get as close as possible to outcome parity as possible, we may actually have to use those protected characteristics. This raises huge practical and ethical issues, since prioritizing for housing using protected characteristics is illegal, and it's really hard basically to ensure that policies that employ such covariance, such characteristics, are non-discriminatory even if they are well-intended. And using unprotected characteristics poses similar challenges, since we said that these only help to the extent that they are predictive of protected ones. So these findings pose huge moral dilemmas. We not only need to balance the different notions of fairness, we also need to balance them with transparency and while maximizing exits from homelessness. Having a system that aligns with the values and moral priorities of stakeholders, including policymakers, people experiencing homelessness, and the public at large, is important to ensure system participation and continued funding and support. On the other hand, designing such a system using pen and paper is virtually impossible. We actually need AI. So to design a system that aligns with the preferences of stakeholders, we must first learn such preferences, such moral priority. What we propose to do is to ask stakeholders a small sequence of pairwise comparison claims. Each query compares two policies that differ in how fair, efficient, and transparent they are. We designed an algorithm that adaptively optimizes the sequence of queries to ask in order to get the maximum information to make a policy recommendation that best aligns with the preferences of stakeholders downstream. We deployed this algorithm on real people on Amazon Mechanical Turk and found that with our approach, we are making the preferred recommendation 2.4 times more often than with the state-of-the-art. Now, having learned the preferences of stakeholders, how can we actually design a policy that's going to align with them? From an AI standpoint, no off-the-shelf solution exists. We need research. In this problem, both people and resources arrive over time, and we must decide on the fly what kind of resource each individual will get, if any. All that we have access to help inform us is historical, self-reported, administrative, observational data. We show mathematically how to obtain from this data the best possible housing allocation policy, the best matching policy that aligns with stakeholder preferences and constraints. The really nice thing with our policy is that in addition to being optimal and fair, it's also really transparent. We applied our approach to data from LA County. We show that with it, we can improve fairness, efficiency, and transparency all at the same time. With our work, we're giving a nod to the community and to policymakers to implement their preferences and increase fairness in a way that aligns with them. We are improving system transparency, which builds trust in the system and helps attract more funds. Simultaneously, we are increasing exits from homelessness by 3%, which in these settings is a big win and helps hundreds of people. AI does risk increasing inequality. Many communities and groups, those who need it the most, have been excluded from the benefit that these technologies can bring. And existing tools cannot be simply applied in this new context. AI research in collaboration with communities has the potential to have huge benefits. We should all be directing more of our resources, time, and energy to designing AI that can help support the most vulnerable, marginalized, and underserved communities. None of this work would be possible without my students and collaborators, all of whom I acknowledge in this flag. Thank you all.